And now, I think last time Pete spoke to most of you was during the executive space course in 2022. He's keep coming back to Israel, I don't know why, but we are so grateful. I know that a lot of you are used to sending him an email, just asking something for advice or professional tips. He's always responding. I will not talk about all the stuff that he did in the US Air Force or at NASA. I'm talking about Pete as a person, because you all know that he's one of our true friends, and it's so important to us, to all of us. Pete, I'm humbled to invite you to the stage. And this is Pete Worden, everyone.
Thank you, Melody. I don't know who that guy you were talking about is. I'd really like to know him. I was also introduced as a scientist, and I am a scientist. I'm an astrophysicist, which sounds really cool. It means you don't get paid very much. But the nice thing about being especially an astrophysicist is because you don't know very much. I have opinions, ideas, hunches. But I can tell you that if you want the answer, send us more money. But what I want to talk about today, and I think I just push this button and it shows up magically, is a topic that's near and dear to me. It's really been my passion since I was a little kid in the 18th century. And I go to a lot of conferences and talk to people, and usually there's somebody walking around with a T-shirt that says, "There is no planet B." I said, "Rubbish." I said, "Of course there is, we just need to find it." So what I want to do is talk today a little bit about what we're doing to find Planet B. And this is a place, and I'll end with that we really want our civilization to go there. So I've given you the bottom line, something they trained me to do in the military. And I know I'm standing between you and more drinks, so we'll try to get through this pretty fast. This is a picture of me a long time ago in a galaxy far away with the first ISU chancellor. This is Arthur C. Clarke and another friend of mine. Yeah, I used to look young. That's what happens. It's radiation, believe me. But Arthur had a really cool quote that said that there's two possibilities exist. Either we are alone in the universe or we are not. And both are equally terrifying, which I think sort of is my motto in life, is we should answer this question. By the way, I'm going to make the assumption that we are alone and that we are the aliens. And we're eventually going to be, expanding outwards. So I gave you the bottom line right up front. But I'm going to talk to you about what we're doing to find Planet B. As noted, I have a couple day jobs, too many, probably about 15. But my title is I'm the chairman of the Breakthrough Prize Foundation. We give out the world's largest science prizes, significantly larger than, as I said earlier yesterday, there's some Swedish prize that I'm not supposed to mention. We give out prizes in fundamental physics, mathematics, and life sciences, and this is a really cool effort. We have one of the neatest parties in Hollywood every year, which I'm invited to because I'm the chairman, but I don't get to do anything other than, it's kind of interesting, the billionaires and the movie stars and university presidents sit together in the central tables, and I get to sit with a scientist. So I'd much rather have my position than those. This is my sponsor, Yuri Milner. He's an Israeli, so it's another reason I keep coming back. This is where the money is. But you also see another gentleman on the stage that looked pretty familiar. That's Stephen Hawking. We announced our search for life in the universe at the Royal Society in 2015. Stephen was our science advisor. I guess you can't get much better than that. Einstein is gone. But it's really cool opportunities to look at some of these questions. Now, the three fundamental questions that Breakthrough has looked at is there intelligent life elsewhere? As I said, I don't think so. I'm not sure there's any here, but I'm not sure. That's why we're looking for it. Is there other life in the universe? I suspect so. In fact, I suspect there's some in our solar system, and we look for that. And finally, and this is a question that's still very open, is can we or our civilization travel between the stars, which is probably the key question of intelligence in the universe. The largest program that Breakthrough has is Breakthrough Listen. It's based at the University of Oxford. I guess it's a semi-reputable university, but we're really proud to be part of the physics department there. This is an effort that over about 15 years has 150 million, so it's well-funded. Mostly what we do is look for radio signals. We also look for optical signals. And it's, I put this up, this is the Parkes radio antenna in New South Wales in Australia. It was built in the early 60s. It's one of the biggest and best radio telescopes still in the world. And we had about 20% of the time on it. And it is about, I think, 4 or 5 years ago, it was actually on Halloween. I remember because I had a bottle of champagne chilled. And the principal investigator called me. I was in Luxembourg and said, I think we have a signal. And I said, wow, and I guzzled the champagne. And then he called back and he said, look, I need to tell you that most of us think this was probably interference. And so I put away the second bottle of champagne and I sent an email to our sponsor and said, okay, we may have a signal. And he said, well, how many people know about it? And I said, well, only the team. And he said, well, tell them not to say anything. Let's see. All right. All right. Tell a joke. Yeah. Two guys. No, never mind. Okay. 2 days later, this article came out, and lots more. So if anybody thinks we could keep things secret, you know, I used to be a military officer, so everybody thinks I know something about, you know, alien spaceships and crashed in New Mexico. Well, actually, they were in Nevada. But I'm sure that'll get on the press someplace, and I'll get in trouble again. But at any rate, you know, we did a lot of analysis. A few months later, we found out that it's probably interference, not 100% certain. It was called Breakthrough Listen Candidate 1, but it was from the very nearest star. And I'll talk a little more about that star, Proxima Centauri. But first of all, we figured we need to go someplace there isn't any interference. So we're working on a program to put a radio telescope on the far side of the moon, so it's blocked from the Earth. And this is something, and by the way, if any of you happen to be very wealthy and want to write me a check, I'll be around afterwards. But this is now feasible because of the commercial development, particularly NASA's Commercial Lunar Payload Services program. So it's quite exciting. And we hope that by the end of the decade we can begin to answer these questions because it's blocked from terrestrial interference. Now let me turn to the nearest star system. You know, I frankly think our solar system is boring. When I was about 6 years old, my mother gave me the first books to actually learn to read, and one was called Planets, and it had all these pictures of planets, but there was no life. And then I had another one called Stars, and at the last page it had a picture of some aliens living on another planet. And I said, okay, I want to be an astronomer. I want to look for these aliens. So that's what I've done. But the nearest star system is much cooler. There's 3 stars. You've probably read about it in the Chinese series, The Three-Body Problem, which, by the way, is complete rubbish. But 2 of the stars are about the size of the sun, and they orbit around each other in 80 years. If you were where we are orbiting the bigger star, you would see the second one about where the orbital of Uranus is. And it would be bright, but you don't get much heat. The third star is really far away. It's about 10,000 times further away than the Earth is from the sun. And it's what's called a red dwarf star. It's a little tiny star. It's only a tenth the mass and only a 10,000th the light output of the sun. But it turns out that 70 or 80% of the stars in the galaxy are red dwarfs. So keep that in mind. But this is a really cool system, and I'll tell you why. A couple years ago, actually about 7 or 8 years ago, we got a call from the European Southern Observatory, and they knew we had money. That's why they called, and they said, "Look, we've discovered evidence of at least 2 planets, and we now know 3 orbiting Proxima Centauri." And that, by the way, is where we got that radio signal from. So, and at least 2 of them appear to be in the habitable zone of Alpha Centauri. So this is or Proxima Centauri. So this is a cool potential planet. The European Southern Observatory had commissioned an artist to make a picture of this, and artists do a really good job. This is a picture of what Proxima Centauri looks, or Proxima b, it's called, looks like. I showed it to Mr. Milner, and he said, we at the time had a program to look at, can we send probes there? He said, why are we funding that if we already know what it looks like? Now, by the way, Proxima b, although it's in the habitable zone and about the size of the Earth, almost assuredly doesn't have life, is probably any life. The reason is that Proxima, the star, is what's called a flare star. Most of these small stars are, and so every few days, the star brightens up by a factor of 100,000 and puts a bunch of radiation out. So if this thing has an atmosphere, like it says here, it was probably blown away billions of years ago. So that's bad news, but there's potentially good news. This is the Very Large Telescope in Chile, and I, as an astronomer, I'm embarrassed that we can't do better jobs at names. By the way, they're building the Extremely Large Telescope, the ELT. Great name. And I'm not kidding you. It was originally going to be called the Overwhelmingly Large Telescope because they had a budget cut. And so it's extremely large. So you can still have the Overwhelmingly Large Telescope. But at any rate, we had about 100 hours of time on this with a special instrument called a coronagraph, interferometer. And we could actually look for planets orbiting the big stars in the Alpha Centauri system, Alpha Centauri A and B. If you're kind of a fan for these sort of things, Alpha Centauri A is called Rigel Kentaurus, so if you're writing science fiction, and Alpha Centauri B is called Ptolemy. So, they're all part of the Alpha Centauri system. At any rate, we found a planet, we think. Interestingly enough, it was in the habitable zone. It's a giant planet, something maybe the size of Saturn. And it's, this was pretty cool. Now, this reminded me, because I'm a science fiction nut, of a set of movies that one just came out recently, which, by the way, are bad. One thing that's really good about them is that it suggests that around this giant planet are moons that could be Earth-like. And so one of the things we're trying to do is, can we find exomoons? And this is a picture from that movie. And I had the idea that, well, why don't we see if the director, who's very wealthy, James Cameron, is willing to fund it. So we got him to talk at our annual conference. I'm still hoping. But we're trying to get more data. So we have a satellite here that, and by the way, if you want to know about it, the program manager is right down there, Kieran, and so he'll answer all the questions. But it's going to be launched here in about a year, and it's going to, we hope, prove that there's a planet there. We also have recent data from the James Webb Space Telescope that says there's a giant planet there. So this is a cool area. This is the world's largest single-mount telescope. It's in Arizona. It's not a very good name. Again, it's called the Large Binocular Telescope. And there's 2 8.5-meter mirrors on the same mount, but we're going to be using that to look. Unfortunately, you can't see Alpha Centauri from the northern hemisphere, but there's other nearby stars that we're beginning to find evidence of planets for. Now, again, these are giant planets. The newest thing, and this is really cool because I'm working on this project, is a few weeks ago, the former head of Google, Eric Schmidt, and his wife, Wendy, announced Schmidt observatories, which is really cool. It's many hundreds of millions of dollars. And there's a number of things being done. There's 3 ground-based telescopes, that totally privately, philanthropically funded. But to me, the neatest thing is the space telescope. This is a 3-meter space telescope that's bigger than Hubble. By the way, I'll talk about, originally we were going to make it much bigger, but, well, I'll tell you in a minute why. But we're going to be looking at a bunch of questions, but to me, the most interesting one is exoplanets. This instrument is equipped with something called a coronagraph, which blocks out the starlight so you can see a planet nearby. Now, just to show you how hard it is, if you had the Earth rotating around Alpha Centauri A, to see it is equivalent to have a searchlight aimed at you, a really powerful searchlight with a firefly, flitting around, and you want to see the firefly. That is hard. It has, less than a billionth the light of the star, and so you need a special instrument to do that. But we have that instrument. There's also one on the Nancy Roman. I think ours is a little better. That's just, my prejudice. But these are both going to be going up around in the next few years. We're planning to have this program launched in 2028. In fact, one of the reasons I'm here is some of the other science, we're looking at working closely with the Ultrasat, the Israeli satellite, which will feed us signals of something strange going on in the universe, so we can point our telescope within about 90 minutes. I'll skip some of these things, but there's a paper. You can find it online. The lead author was Arpita Roy, our head of our observatory. It's Roy et al. And you can find all the specs there. So I won't go into the details. Other than it's what's called an off-axis telescope, which means it's ideal for looking for planets because there's nothing in the way of the beam. Like a normal telescope has a secondary and a hole in the primary. This is at an angle, so there's nothing that scatters light. Now I'll skip that one. Now, it can't find Earth, I don't think. Now, we told the billionaires we might be able to, but that's probably not going to happen. There is a new telescope. This is, I mentioned it, the extremely large telescope. And it has it's much bigger. It's 39 meters. And it has some special instruments that are also looking more in the infrared for evidence of Earth 2. Now, bluntly, it won't find them either. It's just not quite good enough. So the question is, how could we find them? Well, NASA, who I used to work for, and it's a cool agency, mostly, has a program called the Habitable Worlds Observatory. And right now it's planned for the 2040s, and it's cost a lot of money. I hope it goes. But it actually still isn't quite able to find Earth 2.0. It's close, even though it's called Habitable Worlds. So how would we do it? Well, what I'm going to propose here is that we can do something this next decade. I'm an old guy, and I don't want to wait around to the 2040s and find out it's not quite good enough. So what I suggest is something like a public-private partnership. And there's a concept called a star shade. Now, a star shade is interesting. I don't know if I had a picture of it or not. Yes. A star shade is where you don't have the instrument internal to the telescope. You have something that's 10,000 kilometers away that blocks out the starlight. This can find Earth 2.0, and a telescope like the Lazuli or the Nancy Roman is good enough if you put this little star shade, but I'll tell you, this is a really hard rendezvous and docking program for the guys that do that in space, because you got to do that over 10,000 kilometers and keep it there. But the technology is coming along, and we think it can be done. Now, I put this picture up, and I mentioned, we have a 3-meter. Originally, we intended a 6.5-meter telescope. And so the Schmidts paid for the telescope, the mirror. That's it. It's finished. It's in a crate. We're waiting for Mr. Musk or somebody else to build a booster big enough, which we were promised to happen by 27 or 28. Not there, but eventually it will be. Now, this telescope coupled with a star shade would be fabulous. So you know, well, we might be able to do it. So my life's work is to try to make this happen. You know, hopefully we can find Earth Point 2. I think it's out there. I think there's a bunch of them. And we'll find them. Now, the next question is, can we go there? And I'm not going to answer that, but stay tuned, invite me back. I love Israelis and Israeli wine, and we'd like to work with the outstanding technical expertise here. So once again, thank you.